Hi everyone. Today I will be presenting my project on UniSQWareHouse Inventory Management System. This project was developed as a part of my course Programming Algorithms. My name is Chandar Punati. Let's begin by exploring the purpose and core functionalities of this inventory management system. So let's have an overview of the UniSQWareHouse Inventory Management System. This project is titled UniSQWareHouse Inventory Management System in C++23. It was developed as a part of coursework focused on object-oriented and system design principles. The system uses a simple text file named inventory.txt to handle inventory data. It includes essential features such as dating, deleting, adding, and searching for items. The goal was to create a solution that is simple, functional, and compatible across different platforms. Let me now walk through the exclusive summary of the UniSQ Warehouse Inventory Management System. This system is built as a lightweight tool developed using the modern C++23 language standards. It reads from and writes to a plain text file using a textured 6-line format for each inventory record, ensuring consistency and clarity. In terms of core functionality, the application allows users to add new items, delete existing records, and search inventory by name. It is specifically designed for small-scale warehouse operations or academic simulations environment. Lastly, by relying on simple file handling, the system ensures easy data visibility and portability across the platforms. So let us talk about the problem statement and objectives. The problem. Manual inventory tracking is error prone, inefficient, and lacks organization. The system addresses this by digitalizing inventory records using a structured file-based approach. The main objective is to provide a user-friendly tool to manage warehouse items effectively and also simplify the process of querying item detailing and maintaining stock accuracy, and also to minimize technical complexity while ensuring maintainability and usability. Object-oriented programming, OOPS evolution. This consists of mainly five parts: modular design, object encapsulation, logical grouping, future expandability, improved maintenance. OOPS enable modular, reusable, and scalable design for inventory operations. And each inventory item is treated as an object with encapsulated attributes and behaviors. Classes promote logical grouping of data and operations, reducing code duplications. OOPS principles like inheritance and abstraction can be integrated in future upgrades, enhances code readability, and simplifies debugging. So let us analyze the data structure which we use in these certain programs. Mainly, we are considering vectors and linked list, and let's compare and contrast between these two. So the first criteria which we are looking into is access pattern, where vectors provides a random access, where linked list is kind of a sequential access. Implementation of vectors is easy with file systems, where linked list is more complex. And moreover, memory management in vectors is simpler, but linked list provides a dynamic, which is like overheaded one. And also search efficiency is faster in vectors and slower in linked list, as we have to go into a sequence pattern and we have to find every sequence and go through all the lists in the linked list. And suitability, vectors provide it's only better for small and medium data, but linked list is better for frequent insertions. We are selecting vectors by which because of vectors provide effective iteration and a simpler memory management in this context. Selected vectors due to this compatibility with small and medium data sets as well. This slide shows us why we choose a certain type of data structure. So we choose vectors for the first access and first iteration and direct element access by index. And the second most would be the file compatibility. Vectors provide an ideal for a linear data format stored in a text file, which is like inventory.txt. Dynamic resizing. Vectors provide dynamic resizing as new items are added or removed. STL integration, easy integration with C++ STL function for search and modification. Low overhead compared to linked list. Less overhead compared to pointer-based structures, which are similarly called as linked lists. This slide shows us the search algorithm analysis. So mainly, the search algorithm is considered to be having many kind of search theories, but we are considering the binary search, linear, and hashing. Binary search required sorted data, not suitable for file-based unsorted records. Linear search, which is like simpler, reliable, works with unsorted data as well. Hashing. Hashing is mostly like fast lookup and adds up complexity in file storage and collision handling. Linear search is simple, reliable, and works very well for small data sets, which chose they chosen for its direct compatibility with sequential file reading. Uh, this is justification for linear search. The main sequential file processing, inventory records, and reading sequential from text file. Linear search fits naturally with line by line processing of item blocks. Moreover, the implementation is very simpler, not required for pre-sorting or complexity indexing. Minimal code overhead and easy to implement. Reliability for target use. Reliability for datasets with limited volume and real-time updates. These reasons are making a linear search very compatible with the program which we choose. This slide shows a system architecture diagram. Firstly comes the user interface. The user interact through a console manual, like which they have an options like add, delete, and search for the data. There goes inventory manager. Inventory manager processes the commands and invokes file handler. Handlers manages reading, writing to a structured for our dataset, which is like inventory.txt file, and there goes the data file, which is like a structured storage for the inventory.txt. This is a modular design promoting maintainability and possible for future enhancements. That concludes our project on data warehousing for UniSQ Warehouse, uh, which let me conclude and also add the future enhancements can be done to this project mainly. The current achievement through this project is through UniSQ Warehouse meets its objective by offering a reliable inventory management tool through vectors and linear search thing. Code follows OOPS principle, ensuring clarity and extensibility. This kind of model is very effective for small warehouse or academic demonstration purposes. Um, Cannot be limited to that. The future possibilities through this project is like future upgrades through include GUI, JSON, CSV file formats, or database integrations. Demonstrating Demonstrate the practical use of C++, which is 23 version, in the real world software scenarios. These are the differences which I have been taken and consider for this project and implementation of implementation in C++ through various generals. Uh, Thank you, and I appreciate your presence.